So hello students, how are you people? Okay, hope that you all are good. So last time we have learned about number system, that is chapter number first of standard 9, number system. In the previous class we have learned about the different types of numbers. Okay, we have started with the natural numbers. We have learned that natural numbers are the numbers starting from 1, 2 and so on up to infinity. The next we have learned about whole numbers. Whole numbers are the numbers which start from 0, 1, 2 up to infinity. The next we have learned about integers. Integers consist of all the positive numbers, negative numbers and 0. Then we have learned about rational numbers. Rational numbers are the numbers which can be represented in P upon Q form with the condition that Q is never equals to 0. Then next we have learned about irrational numbers. Irrational numbers are the numbers which cannot be represented in P upon Q form. Okay, and then finally we have learned that collection of all these numbers, okay, it is known as real numbers. Okay, now today we are going to learn further about rational number and irrational number, that is the decimal expansion of rational numbers. Okay, so now already we have seen in the previous class that the decimal expansion of a rational number is either terminating or non-terminating recurring. For example, when you divide 2 with 5, the answer is, when we divide 2 with 5, our answer is 0.4, that is we get the remainder 0. And we have considered that whenever we are getting remainder 0, the decimal expansion of the number is terminating. Okay, then let us consider another one. Now 1 upon 3. Now when we divide 1 by 3, our answer is 0.333 and so on. Now here the digit 3 repeats itself again and again. So instead of writing the repeating digits, we write it in a different form, that is 0.3 bar. Remember that the digit which is repeating itself, this bar is present only above this digit. Okay, now since some digits are repeating itself again and again, so we say that the decimal expansion of 1 upon 3 is non-terminating recurring. Non-terminating means the division is not stopping over here. Okay, it goes on. And recurring means some numbers are the in question, some of the digits are repeating itself. Okay, now this is about rational numbers. Now next is about the decimal expansion of an irrational number. Now the decimal expansion of irrational number is non-terminating neither or non-recurring. For example, if you find the square root of 2, okay, the answer is 1.414 and so on. Now here you can see that none of the digits repeat itself in the same manner. Now here it can be seen that 4 is present 2 times, but here after 4 1 is present, here after 4 2 is present. So we cannot say that this is a recurring form, this is non-recurring form. And as the division is not stopping, so we consider it to be non-terminating. Terminating means to stop. Okay, now in these both examples, that is 2 upon 5 is equal to 0.4, 1 upon 3 is equal to 0.3. Here we have converted a number which is in P upon Q form in decimal form. Okay, so in both this example, a number is present in P upon Q form. This we have converted into a decimal form. Okay, now let us learn next topic, that is how to convert a decimal number into P upon Q form. Okay, for example, let us consider a simple example. Now 2.53, here it can be seen that there is no bar present over this 5 or 3. It means that the given number is, or the given decimal expansion is terminating decimal expansion. This one is terminating decimal expansion. Okay, so whenever we are having a terminating decimal expansion, its answer is easy to write. We can just write it as 2. Now after decimal it can be seen that 2 digits are there, so we can write the number as it is, and below this number, that is in denominator, we just have to write 2 zeros after 1. So the p by q form, that is numerator denominator form of 2.53 is 253 upon 100. Similarly, let us consider another example. Suppose if we have 2.567, now it can be written as, you have to write the digits as it is, 567. Now you have to see that how many digits are repeating after this decimal, how many digits are present after this decimal. So it can be seen that 1, 2 and 3 digits are present after the decimal. So in denominator we write here 1, 2, 3 zeros. Okay, so now this is what the p by q form of the given decimal numbers. Okay, that is, we have written the p by q form of terminating decimal numbers. These both are terminating decimal expansion. But now suppose if we have a non-terminating recurring form. Okay, for example, now suppose if we have 0.3 bar or 0.333. Okay, now this decimal is non-terminating decimal. Okay, now let us learn how to convert this non-terminating and decimal expansion, non-terminating but a recurring decimal expansion, in p by q form. Okay, so our given number is 0.3 bar. Okay, so we can write it as, let x equals to 0. Now bar represent that this digit is repeating itself infinite times. Okay, so we can write at least up to 3-4 times. Okay, as per our requirement, I am writing here 3 times. Okay, now let this be our equation number 1. Now we have to move this decimal. Okay, we have to move. First we have to see that how many digits are repeating itself. So there is only one digit, that is, which is present below this bar. So only one digit is present over here, so we will move this decimal one digit to the right. Now we have learned that to move this decimal one digit to the right, we have to multiply it by 10. So now we will multiply both the sides, that is the left hand side and right hand side, by 10. So let us write here, multiplying both the sides by 10, we get, so if you multiply this by 10, we get it as 10x equals 2. And when we multiply this by 10, this decimal will move one digit to the right. So now our number will become 3.33. Okay, if you want, you can add one more 3 over here. This does not create any difference in this one. Okay, now this is our equation number 2. Now we are having two equation in front of us, that is 10x equals to 3.333 and x equals to 3.333. Now our next step is, we have to subtract equation 1 from equation 2. Okay, so subtracting equation 1 from 2, we get, okay, now as we have written 1 from 2, so we have to write this equation 2 first. Okay, so what do we get? 10x equals to 3.333 minus, now our equation number 1 is x equals to 0.333, so we get x equals to 0.333. Okay, you have to take care of these decimals. The number should be written decimal below decimal. Now 10x minus x, 10x minus x can be written as 9x. Okay, whereas now here this 333 and this 333 will get cancelled. 3 minus 0 will be 3, so you will get 9x equals to 3. Now we want to keep this x alone over here. Okay, for that we'll change the side of this 9. Now this 9 is multiplying over here. If you change its side, it will divide on the other side, so you get x equals to 3 upon 9. Therefore x equals to 1 upon 3. That is, we have written in the lowest form. Why? Because it is the standard form. Okay, so now here we have converted. Therefore our question was 0.3 bar. Okay, so this 0.3 bar, it is in decimal expansion form. We have converted into p by q form. Okay, hope you must have understood up till here. Okay, now next, now in this example only one single digit was repeating itself again and again. Let us learn another type of example in which more than one digits are repeating. Now let us consider next example. It is given that show that 1.272727, that is 1.27 bar. Now remember that here these two digits are repeating itself, that is 2 and 7, so the bar will be present over both these two digits. Okay, now we have to represent this 1.27 in 27 bar in p upon q form. Okay, so same procedure we have to follow. Okay, so solution, given number, that is how much, 1.27 bar. So we have to consider, let x equals to 1.27. Now as I told previously, this bar indicate that these digits are repeating itself again and again. For our calculation or for our convenience, we will write this pair, that is these two digits, at least 3 times, and then you can add some dots. Now this is our equation number 1. Okay, now again same condition. What we have to do, we have to check that how many digits are repeating itself, so we will keep these decimals after that digits. Now it can be seen that this 27, that is 27, is repeating itself again and again, that is these two digits are repeating itself. So we have to move this decimal 2 digits to the right, that is here. To move this decimal 2 digits to the right, we have to multiply it by 100. So next step will be multiplying both sides by 100, we get. Now let us see what do we get. Now when we multiply this this x by 100, we get it as 100x equals to. Now remember, when we are multiplying this number by 100, okay, so this decimal will move 2 digits to the right. Let me write an extra step so that it will be easy for you to understand. You will get 100 into x equals to 100 into 1.272727. Now 100 into x, that will be 100x equals to, and now when you are multiplying 100 with this number, this decimal will move 2 digit to the right, so it will become 127 point. Now this number we can write as per our requirement, as here we have written it 3 times after the decimal, so here also we will write this 27 3 times. Okay, now this is our equation number 2. Now our regular step, what you will do, we will subtract equation 1, that is this one, from equation number 2. So now subtracting equation 1 from equation 2 we get. Okay, so first we have to write equation number 2, the equation which comes after from. Okay, so equation number 2 is 100x equals to 127.272727. Okay, now we have to write our equation number 1. Okay, so that is x equals to, now remember, as I told that the decimal should be written below the decimal, so you will get x equals to 1.272727. we have to subtract it. Okay, so now further you will get, now 100x minus 100x minus x, this you will get it as 99x equals to. Okay, now 127 minus, first you have to subtract to the right of decimal, that is same numbers are present, so you will get it as decimal and here 0. Now next one is, that is 127 minus 1. Okay, here also you can, so it will be 126. So therefore you will get x equals to 126 upon 99. Okay, now check whether you can write this number in lowest form or not. So I think we can divide it easily by the number 3, so it can be written as, or therefore x equals to 42 upon 33. Okay, so this is what, now here what we have done, we have written 1.27 bar, 1.27 bar, that is this number is decimal number, we have written it as in p by q form as 42 upon 33. Okay, so I think you must have understood up till here. Is it clear? Now in this example we have seen, let us revise these two examples once again. Here we have learned that only one single digit is repeating, so we have multiplied it by 10. Then in this example 2 digits were repeating, so we have multiplied it by 100. Okay, now let us see the next example. Now next example number 9 is given as, show that 0.2353535, which can be written as 0.235 bar. Now remember that this bar is present over these two digits, that is 35, or we can say 35. Why? What does it indicate? That only these two digits are repeating itself, this number is not repeating itself. Okay, now we have to convert such a number in p upon q form. Okay, so same procedure we have to follow. Solution, now let us write it directly. Let x equals to 0.2353535. Okay, now this is our equation number 1. Now our condition is that we move the decimal. Okay, where how many times we look at the number of digits that are repeating itself, but in this case here we have to move the decimal first. We have to find that how many digits are not repeating itself, so only one digit is there which is not repeating itself, so first we have to keep this decimal over here. So it means that we have to move the decimal one digit to the right. Now for moving this decimal one digit to the right, okay, we have to multiply both the sides of this equation by 10. So multiplying both sides by 10, we get 10 into x equals to 10 into 0.2353535 and so on. So 10 into x, you will get 10x equals to, now this 10 is multiplying to this decimal number, So this decimal will move only one digit to the right. So your number will be now 2.353535 and so on. Now this is our equation number 2. Remember that first what we have done in this case, again I am repeating that here only two digits are repeating, but they are repeating after such a number which is not repeating itself. Okay, so first we have to keep our decimal after such a digit which is not repeating itself. So here what we have done, this digit was not repeating itself, so first we move this decimal only one digit to the right. Okay, suppose if such a case is there that x equals to 54, sorry, if x equals to 0.543 bar, so first we would have multiplied this number. Now where you would have kept this decimal, so we will see that how many digits are not repeating itself. Then during such time it would have become x equals to, now two digits to the right means we have to multiply by 100. During such time it would have become 100x equals to 54.3 bar. Okay, so hope this doubt is clear to you people. Okay, now let us proceed further. Now when we are making this equation number 2, that is this one, now there is no use of this equation number 1 for us. Now we will proceed further. We have to move this decimal, that is this decimal. Now we have to check that how many digits are repeating itself. So it can be seen that 35 is repeating, that is two digits are there which are repeating itself. So now we will move our decimal two digits to the right. So for moving this decimal two digits to right, we have to multiply it by 100. Okay, so now multiplying both sides by 100 we get, okay, so 100 into 10x equals to 100 into 2.353535. Therefore now 100 into 10x can be written as 1000x equals to, now 100 into 2.35, so this decimal will move two digits to the right, so it will become 235.3535, and so is it clear? Now this is our equation number 3. Now as I told that now we don't require this equation number 1. Okay, now we are using only equation number 2 and equation number 3, our regular step. Now this time we have to subtract equation number 2 from equation number 3. Okay, so next you will get, now subtracting equation 2 from equation 3 we get, okay, so now what do we get? We have to write equation number 3 first. 1000x equals to 235.353535 and so on, minus equation number 2 is 10x equals to 2.353535, so 2.353535 and so on. Okay, now it can be seen that these numbers are same to the right of decimal, so it can be directly cancelled. Now 235 minus 2, it is 233, and here 1000x minus 10x will become 990x. Okay, therefore we keep only x on one side, so your next number will be 233 upon 990. So here what we have done, we have converted a decimal number. Further, if you are able to write this number in lowest form, you can convert it into lowest form. Okay, so here what we have done, we have converted a decimal number, that is 0.235 bar, in p upon q form. Okay, so next step will be, therefore 0.235 bar equals to 233 upon 990. Okay, so here we have solved 3 to 4 different type of examples. Hope you all must have understood up till here. So this much is enough. Thank you.